In this lesson, we will learn about window aggregate functions. So aggregate functions are one of the simplest form of window functions, where each aggregated value will be labeled to record in the table. Let's try to understand this with an example. Let's say we have employees detail table. We are already familiar with this table. I have copied over a small subset of data here. So let's say along with each record, we want to get the fraction of employees working in each department out of the total employees who are working in the company. So I've arranged the rows for you so that it's easy to get the department-wise breakdown of the record. Let's figure out the fraction together. So we see that out of the total 6 employees in this table, we have 3 working in the clothing department. So the fraction would mean that total employee in clothing department divided by total employees in the company. So we have 3 employees in the department and total employees, let's assume we have the employees which are seen here, which are 6 employees. So the fraction is 0.5. Similarly, for sports department, 2 employees are there and total are 6. So 2 by 6 becomes 0.33. And for tools, it will be 1 by 6 because we have only 1 employee to department of total 6 employees. Now let's go to the Metabase to write the code. So we will be using employee detail table, employees underscore detail. So let's quickly look at the rows of the data. Let's run this. So this is our data. We have employees, their department, and their salary. So now we want to find fraction of employee. Fraction across department. So in order to do that, I need to get total employee within the department divided by total employee within the. So let's say I select all the columns. And now let's say I want to get total employees within department. I want to count employees. So what I can do is I can do count. And then let's say I can count employee ID. Underscore ID column. Over. So because I want to find this count across departments, I want to partition my data for department. So I can do partition by department. Right? Now let me show you what it will show. So let's say from the table, which is employee underscore detail. What this will do is it will show the total employees within the department. So for each department, it will have same count. For example, for automotive, it has same count with 32 because there are 32 employees within automotive, right? And within beauty, we have 45 employees, right? So, but now what I need to find is I want to divide the fraction. I want to find the fraction. So I want to divide it by total employees. So I can do count start, or let's say again count employee ID by underscore ID, right? I can just write over, do it like this. And I can name it as fraction. I can also put it inside a bracket and let's say fraction of department. So what this will do is it will count the total employees within the data using this over clause and it will show a fraction like this. You can see that it is finding the fraction. Right? I can show you these values separately also. If we can extract this out, which has employees within the partition with department, let's say count department, and I can create this as total count. Now will help you to visualize how this is. So if total count is same for each of the rows, it will the total number of employees, which are 999, and 32 by 999 comes out to be around 0.023, which is around 3.2%, right? You can see this. Now let's look at another example. Let's say you want to get the total salary along with the fraction across each department in the employees record, right? So again, we want to find the fraction salary across the department. So again, I've arranged the rows for you out of our input table so that it's easier to get the breakdown of the record. Now, can you figure out the output that we need? Try to calculate it on your own. Please pause the video and proceed once it is done. Alright, let's solve this together. First, we'll figure out the total salary across each department. Right, so for clothing, the total salary would be the total salary for these 3 rows, assuming that we have only 3 people in the department. So for each of the row, we will have same total department salary. Similarly, we can found it for sports and for tools also. Right, now we need to calculate the fraction across each department out of the total salary of all the employees. So let's say we found the total employee salary, which is around 542k, right? Now in order to find the fraction, we want to divide the salary which we have in each row by the total salary, like this. So it comes out to be around 0.36, which is 36% for clothing. For sport, it comes out to be around 53%, and for tools, it is around 10%. Awesome. Now let's try to write this code in the database and see how we can get this. Alright. So we want to get the fraction salary. Let's write fraction salary, and we want to get it across department. Right, now let's say we do select star because we want to select all the columns. And now let's create that column which finds the total salary across department. Right, so total will be sum. We find the total using sum function. We want to sum the salary. I'll pick salary variable over. Now we want to find the salary for each of the department, total salary across the department. So I'll do partition by department. This will create the total department salary. So now we can use this as a numerator, right? And in the denominator, again, I need the total salary. Let's say sum of salary over. Now within over, I don't need to partition it because I want the total. Let's say total salary, right? Now I'll show you the output and then we'll divide these to get the fraction. So the table name is employees details. We can run this. Right, we can see every department has same value in the total department salary. It changes for a different department, for beauty, automobile, etc. And the total salary is constant. Now to get the fraction salary, just like we get the fraction of employees, I can get the fraction of salary. This will be my numerator. This will be the denominator. We can call it as fraction underscore salary. Right, and we can get this fraction. which is 3.9% for automobile, and for beauty it is 4.8% or 0.04. Now let's try another problem, right? So let's say we want to retrieve the record where employee salary is higher than the average salary associated with their department, right? Once again, I have arranged the rows for you so that it is easy for you to get the department-wise breakdown of the records. Let's work together to get the solution. We will need to first get the average salary for each department, and then we'll see which employee has higher than it, right? So let's first find the average salary across departments. The average salary across department would that we will find total and then divide by the number of rows. It will be total salary for these 3 rows divided by 3. This comes out to be 65, around 60.5. Similarly, we do it for the second department. Again, find their average, which is around 144k. And for tools, because it is only one, so the average is same as the value of the row. Great. But we are not yet done. According to the problem, we want to filter the records that have employee salary greater than the average department salary that are associated with the department. So only few rows should appear. Only these rows where the employee salary is more than the average department salary, those should come in the output. For example, the rows that are highlighted here in blue. Because for the first row, salary of Sydney is more than the average. Second row, it is less. So we won't get this in the output. Third and fourth row again, because they have more than average salary of the department, they will come in the output. And the other 2 rows will not be there in the output. Now let's write the code on the Metabase to solve it using our larger data. So, right. So we want to get the employee salary higher than the average salary associated with the department. Alright, so first let's get the average salary associated with the department. We will do select star, and to find the average salary across department, we use the average function over our salary column. And because we want to find this average over department, we need to partition by department. So I'll partition it by department, and this will give us average department salary, right? And then let's read the data from the table. Detail. Okay. All right. So we have the average salary across each of the department for automobile and beauty, etc. Now what we want to do is we want to compare this salary, right? We want to compare this salary with the actual salary of the employee. Now I cannot apply a where condition here because this column we are creating in the select statement, right? I cannot apply like this. So what I can do is one thing is I can use a subquery. So I can use a subquery here, and let's say this is table. We call it as table 2, right? And now within this table we have the column which is average departments. So I can apply a where condition here, right? Because within this table we have both the columns, salary and average department. So I can write here where salary, table salary, we want to provide yes, table to salary is greater than table to dot average departments, right? We want to filter the rows where the employee salary is more than the average departments. So I can do select a table. Let's say we end this with semicolon, and we can run. All right, now for every row you will see that the salary is more than average department for each of them. All right, now let's try one more problem. So suppose that we want to calculate the statistical range of employee salary for each department. Once again, I have arranged the rows for you so that it is easier to break down. Let's work together to get the solution. Again, this one is quite straightforward. If you remember from the basic statistics from the school days, we recall that range is the maximum value minus the minimum value, right? So because I want to calculate the range of employee salary for each department, means that its maximum salary within the department minus the minimum salary within the same department, right? Now we want to find this across all the departments. For example, for clothing department, right? Maximum minus minimum. Maximum is 95,313 and minimum is 28,995. The difference between the two is 66,618. So for each row, I want to get this value. Similarly, for sports also, because we have only two rows, it will be whichever is higher minus the lesser one. And for the tools, because min and max would be same, because we have only one row, that's why we get same zero value. Now let's again write this code on Metabase and see how it. Right, so we want to find the range of the employee salary across each department. So again, we'll select all the rows, all the columns, in fact, using select star, and range is the max minus min. So I want to find the range of salary. So maximum salary over. Do we need partition for this? Think about it. We want to find this across department. So we need a partition by department. So this is the max salary minus I want to get the minimum salary. So similarly, I can just find this partition, the department, and it will give me statistical underscore range, will give me the range, and we can read data from our table, which is employee details. And I can run this like this. So we can see that for each department, we get same range, same value of range, right? For automobile, it looks like around 160K is max, minimum is around 56K, right? Or in fact, it could be even less, 51K also. I think minimum is 29K, and around 60K minus 29K comes out to be around 1. So we got the range. Alright, now let's summarize what we learned within this session. We looked at different window aggregate function. There was count, which gave us the count of item across each partition. Then we looked at sum, which gave us the sum of item across each partition. Then we looked at min and max, which we used to find the range. Right? It again works across the items across each partition. Similar is the average, which would give us average of items across each of the partition. Right, now let's look at the general syntax that we use. So can you select our columns and then the function, window aggregate function, which could be count, sum, min, max, average, and then the column on which we want to apply it over the partition. Great. So in the next session, we will understand framing in the window function.